Now we are going to discuss about second order system. So second order system exhibit a wide range of response that must be analyzed and described. So this system has only two poles. Like the first order system, it may or may not have zeros. As long as it has two poles, it is called second order system. Unlike first order system, which is change the speed when the parameter is changed, but for second order system, the changes of the parameters will change also the form of the response. This is because analysis of the second order system is more complex compared to the first order system because of more quantity will be measured. I mean more parameters that we have to measure at the transient response. So the quantities that are setting time, TS, TR, rise time, final value, peak value, TP, and also percentage of overshoot. So to analyze the system, several conditions need to taken into account since the output response for the system consists of several forms depending on pole location on the S-plane. Figure 5 here shows a general block diagram for a second order system. As you can see here, this is a GS, which is equal to omega n squared divided by S times S plus 2 zeta omega n, where omega n is a natural frequency and zeta here is a damping ratio. So this is a closed loop system with the HS equal to 1 because we have unity feedback, negative unity feedback here, and the output for the system is CS and the input for the system is R of S. So general equation for a second order system can be obtained by having a closed loop transfer function as follows. So we use this equation, we use this formula to get the transfer function for the overall system, for the closed loop system, where CS over RS equal to GS, this one, divided by 1 plus this one GS times HS. HS here is equal to 1. So after we solve this, we get CS over RS equal to omega n square divided by S square plus 2 zeta omega n S plus omega n square. Okay, this is a general equation for a second order system. So the parameter omega and zeta here can be obtained by getting a closed loop transfer function for the whole system in the same format and then compare both coefficient, which means after we get the transfer function, after we get the transfer function for the system, we can compare with this general equation to get the value of zeta and omega n. Let's say we have transfer function gs equal to 1 plus s squared plus as plus b. So the closed loop transfer function can be obtained as follows. So we use the same formula as before. We use feedback formula where cs over rs equal to kgs over 1 plus gs hs. Gs here is referred to this gs and hs is referred to the unity feedback equal to 1. So after we solve this, we get cs over rs equal to k divided by s squared plus as plus b plus k. So and then we compare the coefficient with the general equation for the second order system that we have derived before. So based on these two equations, we can see that this omega n square equal to b plus k. So from there, we can get the value of omega n, where omega n square equal to b plus k. So omega n become set b plus k. And next, this one, 2 zeta omega n, if we compare with this equation, this 2 zeta omega n equal to a. So from there, we can get the value of zeta equal to, where zeta is equal to a divided by 2 times set b plus k. Let us look at this example. So in this example, we have to determine natural frequency omega n and damping ratio zeta. So this system have transfer function Gs equal to 16 over S times S plus 5. So this is a closed loop system with unity feedback. So in order to solve this problem, first we have to get the transfer function for the closed loop system by using this formula. So after doing so, we have the result for Cs over S equal to 4 square divided by S square plus 5S plus 4 square. Okay, by compare with the general equation for the second order system, so we can get the value of omega n, natural frequency, by take this value and this value where omega n square equal to 4 square. So from there we can get the value of omega n is equal to 4. And then next, in order to get the value for zeta, so we just take this part, 2 zeta omega n, and then compare with this results. So based on this result, so we know that 2 zeta omega n is equal to 5. So from there we can get the value for zeta is equal to 0.625. Characteristic equation. So what is characteristic equation? So this is referred to the equation that can be used to obtain information that is deemed relevant to the performance of a system. So it can obtain by equaling the denominator of the closed loop transfer function of the second order system to 0. So from the general transfer function of the second order system, like we derived before, so the characteristic equation for from that transfer function is S square plus 2 zeta omega n S plus omega n square equal to 0. So from this equation, so the closed loop poles can be obtained by getting the root of characteristic equation as follows. So from here, from this equation, we just factorize and then we get the closed loop pole. So the closed loop pole for this characteristic equation is S1, S2 equal to negative zeta omega n plus minus j omega n times Z1 minus zeta square. So this equation can be simplified like this, where S1, S2 is equal to S1, S2 mean pole number 1 and pole number 2 equal to negative sigma plus j plus minus j omega d. So sigma here is represent this negative zeta omega n. Okay, this one is the damping factor of the system. So j omega d here is referred to this omega n times Z1 minus zeta square. Okay, this is the damping frequency of the system. All these parameters can be obtained by plotting the location of pole on this S-plane. So as you can see from this S-plane, so the distance from this origin to this point is referred to the zeta omega n value. And the difference from this origin to this point is referred to the omega d value. So that means zeta omega n is referred to the real value and omega d is referred to the imaginary value of the system. So the distance from this origin to this pole is a omega n. Omega n is a natural frequency. So from this value zeta omega n and omega d, we can calculate omega n by using theorem Pythagoras, where omega n in order to obtain this omega n, so we can use this formula. So omega n equal to zeta omega n, this value square, plus this value omega d square. Okay, so the angle from here to here we call theta. So based on this value of theta, we can calculate zeta. So where zeta is the is equal to cos theta. So this value of theta we can get from also from the theorem Pythagoras.